Good morning, students. Now we will solve the second problem on cantilever beam. Again, the Young's modulus is 2 into 10 raised to 5 and Poisson's ratio is 0.3. You see here, on the left side, the beam is fixed and the 2-point loads have been given at point B and C of magnitude 10 Newton and 20 Newton. Okay. The cross section is again 50 by 50. So first we have to solve it by analytical method by using this method shear force. So 3 points are there means 3 shear forces you will get. Then again bending moment at 3 points, separate bending moments you have to find, and then you have to draw the shear force and bending moment diagram. Then you have to draw the comparison table. Okay, and you have to substitute the values of shear force, that is maximum value and minimum value, and bending moment maximum and minimum. So in this, whichever is maximum and minimum, that value you have to substitute. Now the same thing we will solve it in ANSYS and let us compare the result. Okay, so let us start. So again in ANSYS, go to file, clear, start new, do not read file, okay, yes, and go to preferences, structural, okay, go to preprocessor, element type, add, edit, delete, add. Now it is a beam problem, so select beam, 2 noded, 188, okay, close, minimize this, go to material properties. Here again it is a beam problem, so no using of real constant. Go to material properties directly, material model, structural, linear, elastic, isotropic. Substitute the values of Young's modulus and Poisson's ratio. Put these values 2 E5. Poisson's ratio is 0.3. Say okay, close. Then go to section. The B problem, so you should go to section. Then in section go to beam. Then common section. Substitute the values of section. It is 50 by 50. Put this value 50 by 50. Then say okay. So section is created. Now go to modeling. In modeling, go to create. Now what you have to do? You have to create now 3 points A, B, and C, and in between them you have to create the lines. So this is a beam problem. So you should use key points. Inactive CS. First point direction is location is 0. Apply. Second point is here. It is at a distance of 200 mm from starting. So 200, apply. Third point, it is at a distance of total 400 mm from starting. Third point is at a distance of 400 mm from starting. So substitute that value and say okay. So 3 points have been created. So in between there is a line. So that line you have to create now. So for that, close this, go to lines directly. And in lines, again go in line and select straight line. Now what you have to do, directly select point 1 and select point 2. Then select point 2 and select point 3. So now your lines have been created. Just say okay. Minimize this. Now what you have to do, you have to do the meshing. So go to meshing, mesh tool, line, set, select both the lines, say okay. Then here number of element division, we will put it as 200 again. Then say okay. And again go to mesh tool. Now what you should say, mesh. Then select these 2 lines and say okay. Now it has been completely meshed. So now what you have to do, you have to fix this side and you have to apply the 2-point loads. Fix and apply these 2-point loads. Now for that what you have to do, you have to go to solution. In that, go to define loads. In define loads, you go to apply, then go to structural, and go to displacement. Now we need the points to apply the displacement and the point loads. For that, what you have to do, go to plot control, sorry, go to plot and say key points, and say here key points. So now we are able to see the points now. Now we can directly apply. So displacement on key points, so we are fixing the first point because this side we have to fix. So we have selected this, then say OK, say all degrees of freedom, and say OK, it is fixed now. Now we have to apply the force here at point B and C. Let us apply that to minimize this displacement. Select force on key points. First select point 2 and say OK. Direction is Fy. The value is minus 10. So put here minus 10. If you put plus 10, the force will go in a 4 direction. So put minus 10 and say apply. The force is applied at second point. Now you have to apply the force here also. So what you have to do, again select this point, say OK. Direction is Fy again. Value is 20 now. So put the value minus 20. Don't forget to put the direction Fy. Okay. And say OK. The force is applied now. Okay. Now what you have to do, directly solve the problem. So go in this option that is solve and say current LS. Say OK. Solution is done. Okay. So you have solved now. Now what you have to do, go to general post processor. So what I have told, whenever you go to general post processor, first you have to go to element table data. Element table data. Then in that go to define table and say add, come down by sequence ls1, apply, and again use that 4 codes, that is 3, 16, 6, 19 by sequence SNSIC 3, apply by sequence 16, apply, come down 6, apply, come down 19. Okay. So these are the 4 codes 3, 16, 6, 19. So close this. Now what you have to do, go to plot result, which is in blue color. Go to plot result. Then say contour plot. Then in this, the last option, line element result. Go here. Now select 3 and below you select 16 and say OK. So this is your bending moment diagram. So whatever the minimum value is there, that you have to put it in maximum. So this minus 9985 is there. So you have to write this in table here minus 9985. So this is the maximum value. How much we got by analytical method? 10,000. So here we are getting 9,985. That is nearby value. It is correct. Then minimum is minus 10. So minus 10. So analytical method we got 0 and this is minus 10. That is nearby value. So no problem. Okay. So like this you have to do. Then now what you have to do, again click on line element result, is again on same option. Now you select 6 and you select 19 and say OK. So this is your shear force diagram. So analytical method we got like this on top portion, but in ANSYS we are getting below. So ANSYS will give ulta. Okay. So whatever minimum is there, that you put it in maximum. Whatever maximum is there, that you put it in minimum. So maximum is minus 30, minimum is minus 20. So put it here 30, 20. So this is your complete table. So like this you have to do the analysis. Okay. So this completes the second problem. Thank you.